Today's presentation is in regards to the Extreme Edge Orchestrator module of the 5G-IANA platform, the EEO, previously known as the DMLO. The Extreme Edge Orchestrator, the main responsibility is the lifecycle management of the processing task on the Extreme Edge devices, on the vehicular onboard units, OBUs. Its main functionality is the smart device selection of these devices, of which of these devices will participate in each processing task based on the criteria that are set by the user. These LCM lifecycle management policies are imposed by the DMLO via the policy executor component of the platform that is developed by Ubitech. This actually imposes such policies using the underlying Kubernetes network of the 5G-IANA platform, and it handles all events in regards to the activation and deactivation of the devices, which essentially means the scaling or even removal of the resources. In our case, that's the Docker containers that run applications. In our demonstration, we will be showcasing the implemented components of use case 6. Now, use case 6 handles the federated AI/ML for predictive quality of service task. This is based on the Flower framework, an open source library that performs federated learning. That means distributed AI/ML training on the OBUs. Basically, it includes two kinds of containers, several training nodes that run on the vehicular OBUs, and one aggregation node that runs on the server. This mobile OBUs act as Flower clients and are responsible for the training, and the aggregation server is responsible for the aggregation of the training models and the orchestration of the task, the processing task thereafter. In our demonstration, the components of use case 6 will be used as facilitators in order to understand how the Extreme Edge Orchestrator manages to orchestrate these tasks. And in our scenario, we will have a total of 4 OBUs that are located in the premises of Nokia outside Ulm. 2 OBUs are static in the lab, and the other 2 OBUs are in the vehicles, so they are able to move around. These 2 are depicted in the map, as you can see in our screen, the mobile OBUs in the top right corner of the map, and in the top left there are the static OBUs. As you can see now, the training has already been initiated. We have defined a couple of restrictions for our training, so the maximum number of OBUs will be that will participate in our task will be 3. And also we have predefined an area of interest, this black bounding box that is shown on our screen. So we will only select vehicles, the Extreme Edge Orchestrator will only select vehicles that are inside this bounding box. So as you can see now, a total of 3 vehicles are selected. We can even see that on the event log in the bottom of our screen. There are a total of 3 OBUs with IDs 1, 3, and 0 that are selected for the training. And now we will present the first event, which is that one OBU, mobile OBU, exits this area of interest, and now the Extreme Edge Orchestrator is supposed to, through the monitoring platform, understand that one OBU is out of the area of interest and initiate the process of deactivation. Now we will check the backend log of the aggregation node to check that one OBU is indeed has left the training. As you can see, there are a total of 2 out of 3 clients active at the moment. and it will continue training with 2 out of 3 OBUs total, since the third OBU doesn't meet the criteria anymore. And also we can see from the backend logs of the underlying Kubernetes network that only 2 out of 3 training nodes are active, and 1 is in the terminating status, as you can see, which means that the third OBU that has left the bounding box, the area of interest, the AOI, is deactivated. And this is also validated in our map, since the color has changed from green to red, which represents a node that is not selected, is deactivated. Meanwhile, we can see in the left part of of the Extreme Edge Orchestrator GUI that the progress of the training, how is the progress of the training. We have some statistics and some graphs in regards to the convergence, which is represented by the training loss graph, and also the accuracy of the training task, and how this changes in the course of time. Also, we can see the involved resource consumption costs in the bottom left of the GUI, which show the total energy consumed and the total traffic volume, the bandwidth that is consumed for these training tasks. All these statistics are collected via the monitoring, the Prometheus monitoring platform, which is enabled via the underlying Kubernetes network from the Extreme Edge Orchestrator, and it allows the user to have a continuous monitoring of the associated costs of the system for the training task. Our next demonstration will be another event, activation event. So the node that exit the area of interest before will re-enter. You will see the red mark in the top right corner of the screen moving towards the area of interest again. So we'll be showcasing a new activation event. The Extreme Edge Orchestrator is expected via the monitoring platform to that tracks the location of all the nodes to identify that the node has re-entered this area of interest, and then what is the expected behavior is to activate it, so it should re-enter the training task, and also the color of the node should change to green. We will also check this via the event log. As you can see, the end user has a complete view of what is going on throughout the system, not only in regards to the processing nodes, but also the global centralized statistics, such as the progress of the training task, the resource consumption, and all the major event logs that occur in the system, and is able to monitor and even stop the process at all times, giving a complete control over the system. And also is able to monitor in regards to the criteria that are already defined by the user in regards to the device characteristics, for example, or processing capacity of the devices, and how these affect the training task throughout the process. As you can see, the red dot is moving towards the area of interest again. This is the vehicle that is actually going into the area as we speak, and is also represented in our map. And meanwhile, in the event log, we can see that the Extreme Edge Orchestrator has identified this change and will fire a new activation execution command. We will cross-check this in the backend logs of our system. So these are the aggregation, the server's logs that we will first check, and indeed see that a new client has been added and is able to continue the training with a total of 3 clients instead of 2 that was before. As you can see that in the screen as we speak, 3 out of 3 are selected, which is indeed the maximum number that is allowed via our settings, and we will also validate it through the underlying Kubernetes framework. We can see here that there are a total of 3 pods running the training task at the moment. This is also depicted in the top left part of the screen, where the convergence and the accuracy of the training task change in the course of time, and also it is visualized in the map, where we can see that the third OBU is activated and the color has changed to green. So the final thing we will showcase is the matchmaking capability of the Extreme Edge Orchestrator. So the 4th OBU, which is the second vehicle, will be instructed to enter the area. We will see that in the map. So basically, since we have set a maximum number of 3 clients in our criteria, the expected behavior of the Extreme Edge Orchestrator is to deny access to this OBU in the training process. So basically, it should identify that there is another available OBU for training, but still it should remain red, so not selected as a client. Let's see. So now you can see that the red dot is moving towards the area of interest in the top right part of the map. And it gradually enters this area of interest, this black bounding box. And now we will check the event log to see whether the Extreme Edge Orchestrator has identified that. We can see that the OBU with ID 4 has entered the area of interest, but is ignored. So it's not selected as a client, since the maximum number of users defined is already reached. So the matchmaking of the criteria is validated. So the training will continue with a total of 3 clients. Overall, the Extreme Edge Orchestrator can utilize the monitoring information that is obtained from the platform, and then perform smart selection using this predefined user criteria for the Extreme Edge devices for any processing task, such as video stream or analytics. In our case, we have showcased that for a distributed AI/ML training task, which is indeed challenging. This layer of intelligence that we have introduced before the client selection process is expected to decrease disruptions, for example, during overload of RAM or CPU, enhance energy and resource efficiency in general, and optimize the processing capabilities of the platform in regards to the Extreme Edge devices. And in particular, when it comes to on-device learning, which poses several challenges for the devices in terms of consumption, processing, and the overall cost.